All right, in this video, we're going to look at the answer to the question, how can two angles be related? Just like two people could be related, mother, father, kids, uncle, whatever. Angles can have relationships with other angles. Here are some relationships they can have. 1. Complementary angles. Complementary angles have measures that add up to 90 degrees. So if I have two angles that together make a right angle, they are complementary angles. If I have two angles that don't come together to make a right angle but happen to have measures that still add up to 90, they are complementary angles. Same deal with supplementary angles. Two angles that come together to make a straight line that's 180 degrees, they have measures that add up to 180. They are supplementary. Or if they're like just completely apart from each other, one lives in Venus, the other lives in Mars, but they happen to have degrees or measurements that add up to 180, they are supplementary angles. Next we've got adjacent angles. Adjacent angles don't necessarily add up to anything, they're just right next to each other. Here are some examples of angles that aren't adjacent. These two, not really next to each other, they're not touching. These two, well, they're touching, but adjacent means that they have the same vertex. So these aren't adjacent. They have to come out from the same point, like a flower. Like a flower. These two, and what I mean to illustrate here is that there's a big angle, ABD, and a smaller angle, CBD, that's inside ABD. These aren't next to each other. They're not adjacent. We have one angle that's inside the other. So adjacent, like rays coming out of a common vertex here, and they're right next to each other. Here, not next to each other. Here, next to each other, but not coming out of the same vertex, like flowers from whatever. And here, yes, coming out of the same vertex, but one's inside the other. They aren't adjacent. All right. Next. All right, next we have linear pairs. Linear pairs are two angles that together make a straight line. We actually saw an example of this in the last set. They happen to be, by the way, supplementary. They add up to 180 degrees. We also have vertical angles. When two lines cross, the angles that are across from each other are called vertical angles, and they are, by the way, congruent. They have the same measure. Don't be confused. Vertical doesn't mean up and down the way we normally think of it. In fact, I have the foggiest idea why they're called vertical angles. I should look into that. These are vertical, but these are also vertical. All that matters is that the two lines cross, and I got the angles that are directly across from each other. Those are vertical, and they are congruent. They have the same measure. They're the same size. Next, we're going to take a look at using complementary angles or supplementary or whatever to solve some quote-unquote problems. Really, we're just adding some algebra in here and using some simple, really here, you're actually kind of doing a proof, believe it or not. Anyways, so I got two angles. They are complementary. They add up to 90 degrees. One's a 30-degree angle. One is a who knows what degree angle. So we set up an equation and we say that the unknown angle plus the 30-degree angle equals the 90-degree angle. Then we subtract 30 from each side and we get 60 degrees. I'm going to say this. You might look at this and be like, 30 plus what is 90? Duh, 60. But it's a good idea to remember how to set up this equation, that the two angle measures add up to 90. So angle measure 1 plus angle measure 2 equals 90. And the reason is you get some weird numbers like weird fractions, weird decimals, or maybe, like in the next example, some expressions. And then it gets more difficult. But if you remember the setup, set up the equation, angle 1 plus angle 2 equals 90. It'll work every time. All right, let's see here. Moving on down, we have, okay, this one here, so many mistakes. I don't know, I royally screwed this up. I was writing stuff all over the place. But I have angle 1, and it has a measure of 3x plus 10 degrees, and I have angle 2, and it has a measure of 5x. So here's the sample where we really do have to set up an equation, and I say 5x plus 3x plus 10. So I'm just taking the two expressions and adding them together, putting a plus in the middle. I combine like terms. 3x and 5x makes 8x, and then there's the 10. Now I have to solve the equation. Take 10 from each side, and I have 8 equals 8x, blah, 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 x equals 10. In a lot of problems, you might stop there. They might say, hey, here's a relationship between two angles, and I want you to find x. I found x. It's 10. But sometimes they'll ask you to go a step further and find like the measure of angle 1 or the measure of angle 2. So in that case, you would just go back to the expression that you were given for angle 1 or angle 2, depending on which one you're being asked to find, and you substitute 10 for x, and then just work it out what it is. In this case, it turns out to be 40 degrees for angle 1 and 50 degrees for angle 2. Next up. Take a look at a similar example for using supplementary angles. So here, I've got two angles that come together to make a straight line. They're a linear pair. They're supplementary. And I say that these two angles, angle x, or not angle x, it's not called angle x, it is an angle with x degrees, some unknown number of degrees right there, plus the 39 degree angle. They're going to add up to 180. So to solve this, I have to take 39 from each side, and I get 141 degrees for the unknown angle. By the way, that's pretty much the same as supplementary angles. Here's another example. This one's a little more, I want to point this out. Here we have two parallel lines and a transversal crossing them, and angle 1 and angle 2. We won't get to this till chapter 3, but they are supplementary, even though they don't come together. They're not a linear pair, but they happen to be supplementary. They add up to 180 degrees. So I have 3x plus 5, and I have 4x plus 35. I add them together, here and here. There's the plus in the middle. They equal 180. That's the setup for the equation. Now I have to combine like terms. 3x and 4x makes 7x, and 5 and 35 makes 40. And now I just go ahead and solve this equation, and you can kind of work that out for yourself. Pause it. Now that you've worked that up for yourself, you find out that 20 equals x. And that was the whole find x stage. Now say the problem asks you to go a step further and actually figure out what the angles were. Well, I know that x was 20, so I go back into the expression for the first angle, 3x plus 5. I replace x with 20, and I get 65. I go into the second angle, do the same thing, and I get 115 for the second angle. All right. If I want to use linear pairs to solve problems, wait. Yeah, it's the same thing we did above, so I go back up here. All right. 9 out of 10 times, 10 out of 10 times. If you have to solve a problem like this that involves a linear pair, it's because they're supplementary. You just set it up this way. All right, so just to review, we had supplementary angles, we had complementary angles, we had vertical angles, which are the same measure, we had adjacent angles, all sorts of ways that angles, a pair of angles could be related to each other. And some ways that we can use them to, quote unquote, solve problems. All right.